Hello champs, welcome to my channel Chemistry by ANR. Now this part is for you class 9 champs, those who have to master the equations of motion. Now when we talk about equations of motion, there are many equations of motion, but we need to understand what they are. These equations of motions are known as kinematic equation. What are they known as? They are known as kinematic equation of motion. Now in a straight line with constant speed, this you need to keep in mind that whatever equation of motion we will be dealing with, they will be the cases where the body is moving with constant acceleration. Okay. Now, if the acceleration is constant, that means at every instant, the acceleration will be equal to the average acceleration over any time interval. That means over any time interval, the value of the acceleration is same as average acceleration at any instant. Using the definition of average acceleration. Now we have seen what is average acceleration in the previous modules, where we know that acceleration is actually the change in the velocity with respect to time. Now acceleration, which is the average acceleration, is given by A is equal to V minus U by T, where V is the final velocity, U is the initial velocity, and T is the time interval. So over here we can just cross multiply this and we can say A into T is equal to V minus U. So what can we say? We can say AT is equal to V minus U by cross multiplication. So now we change the side and we can say V is equal to U plus AT. Now this is one of the equation of motion, or rather we can say this is the first equation of motion. Which one? 4.4a. V is equal to U plus AT. Now here we can see this is in the form of y is equal to mx plus c. Y is equal to mx plus c. If we plot velocity on the y-axis and time on the x-axis, then we can say y, which is velocity, is equal to m into x plus c. Why? Because x is t, and in that case m will be a, that is the average acceleration. Okay, so here from the velocity time graph, what can we see is we can see that slope of the line from the graph will give acceleration. So slope of the graph gives acceleration in a velocity time graph. And the graph is a straight line indicating that the velocity changes with constant acceleration. Because the acceleration is constant, so at any instant, the acceleration should be equal to the average acceleration over any time interval. Okay, and the slope of the line will give you the acceleration in the velocity time plot. Now let us see. Okay, fine. The slope of the line gives acceleration. Another thing we need to mark over here, that is the displacement s of the object during the time interval. Displacement s of the object during the time interval t will be given by the area under the plot. Now, which is the area under the plot? This is the nature of the plot. So area under the plot means this part is the area under the plot. This total area under the plot is this part. Now if we see minutely the diagram over here, We can see it is formed of one rectangle and one triangle. If we can find the area of the rectangle separately and the area of the triangle separately, and we do add it, then we will get the displacement S of the object during the time interval t. So area of the rectangle OACD is equal to OA into DO, right? So it is OA. Now OA means this much. Okay. So OA means U. If we see OA, we will see it is equivalent to U. So this is it. OA is equal to U. And DO is equivalent to the time interval, which is T. So DO is equal to the time interval, which is T. And BC is equal to. So what did we get? We have got the area of the rectangle, this one, U into T. Because we know area of the rectangle is equal to OA into OT. So we have got U into T plus area of the triangle, half into base into height. If we say the base is CA, so CA is parallel to OD. And if OD is equal to D, CA from the plot is very much clear, equal to OD again. So then in that case, CA is equal to T, right? So CA is equal to T. Now over here BC, CA is equal to T, and over here BC is equal to this part. BC is equal to EA. Now if the total part is V, then EA should be V minus U. How come? Because EA is equal to OE minus OA. So OE minus OA. OE is V, which is the final velocity, and OA is U, which is the initial velocity. So we can say this is equal to V minus U. And hence we got this expression. What did we get? We have got S is equal to UT plus half T into AT. That is S is equal to UT plus half AT square. So we will say this is the second equation of motion that we have got. And what is that? S is equal to UT plus half AT square. What was the previous one? V is equal to U plus AT. Now do write these equations of motion separately such that you remember them properly. Now if you are told to derive it, then you can derive it from this, like we have derived it here, that if we have to find the displacement S of the object for the time interval T, then we have to find the area under the plot. So area under the plot means OABD, the way we have derived, the same way you can derive. Now these two equations of motions are the basic equations of motions. Others can be derived from them. Like if we see that from here, from the first one, we can say V is equal to this one. V is equal to U plus AT, right? We saw V is equal to U plus AT. So if V is equal to U plus AT, then we can say T is equal to V minus U by A. So if we get the value of T and we place the value of T in equation 4.4b, then in place of T, like S is equal to UT plus half AT square. So U we know, in place of T we are writing V minus U by A. This we are writing minus half AT square. This is again T. So we are doing square of it. Now when you simplify it, you will get V square is equal to U square plus 2AS. So this is the third equation of motion, which is derived equation of motion. Again from the first one, V is equal to U plus AT. We can say that, okay, fine. So T is equal to V minus U by A. And so you can simply place it in the second equation and you're getting the third one. So I hope how you have got the three set of equations of motions, they are clear and they can be written as the kinematic equations. So these kinematic equations are valid only when the acceleration is constant. This you have to keep in mind. So while using these equations of motion in a straight line in one direction, what you have to remember is the distance traveled and magnitude of displacement are equal. Again, we have assumed that the speed and the magnitude of velocity are also equal, right? So let us see this application of the concept which says, suppose a car is moving on a highway and brakes are applied. So if brakes are applied, then the acceleration is negative and this is known as deceleration or retardation. Remember one thing, the value of retardation is only the magnitude because retardation means negative acceleration. But if you write acceleration as A, you have to write with the negative sign. So this is negative of 4 meter per second square. Okay. Acceleration is negative of 4 meter per second square. How much will be the distance traveled by the car? So you have to find S, right? S is unknown. Before coming to a stop, if I say before coming to a stop, that means the final velocity is 0. So this final velocity is 0. Acceleration is negative 4 meter per second square. And how much time will the distance travel by the car? So how much? So no, how much will be the distance travel? That means something that relates V, A and S. And what is that? V square is equal to U square plus 2AS. You have to assume here if the car was moving with a velocity of 54 kilometer per hour. So convert this kilometer per hour to meter per second. And if you do this, so what it is? How can you convert kilometer per hour to meter per second? So this if you keep in mind, then you can actually do the conversions easily. Okay. So what you have to do? Convert first kilometer per hour to meter per second. For that, you have to multiply by 18 by 5. Okay. So, kilometer per hour to meter per second. Okay, 5 by 18 you have to multiply. So, what you will do? It is actually 54. It is actually 54 into 5 by 18. You will get 15 meter per second, right? So you can try out for your own that what is the value of 54 into 5 by 18. And if you calculate, you'll definitely end up to 15. So it is 15 meter per second. That is your initial velocity. The moment you write U is equal to 15 meter per second, so you get what? V square is equal to U square plus 2AS. Final velocity is 0. You have two different values of U. So this approach is keeping U intact and you get a final relation S is equal to U square divided by 8. And now you place the value of U in meter per second just the way I said. That kilometer per hour to meter per second, multiply it by 5 by 18. If you do the reverse, meter per second to kilometer per hour, maybe that in some of the numerical you need to do that. So for that you will multiply by 18 by 5, right? So bridging science and society, this is something which maybe you have heard or may not heard also. You can do a research for it. That is vehicle to vehicle communication technology. That is V to V communication technology. What is that? It is a technology that is a communication system that allows vehicles to exchange information wirelessly with nearby vehicles in the real time. And it actually, this technology, what it does is it actually sends signal. Okay. And you get alert, and for that each vehicle continuously sends and receives the data, like what is the speed of the vehicle which is near you, what is the position, what is the direction of travel, what is the acceleration or braking status. That is, before the vehicle, the light of the brake you can see, you will get the signal. And this is very important in order to avoid accidents or any mishap. So what I said is vehicle to vehicle, V to V communication technology. Do a little more research about it and get to know something new. So bye all of you. We will meet in the next session of motion.